Hello, my dear students. Welcome to today's class. Today I will be dealing with the next topic, which is called as Karnaugh map, which is very important exam point of view, which is having 5 mark question. It will be having 5 mark question. So we have already covered the simplification of Boolean expression, in which we have studied many topics like soft, pause, winter, maximum, and also in the first year syllabus you have studied how to simplify a Boolean expression with the help of Boolean laws and identities. Now you will be studying a new concept, otherwise a new method of solving the Boolean expressions. So K-map. What is Karnaugh map, which is also called as K-map? Karnaugh map, called as K-map. Definition: it is the graphical method of simplifying K-map. Okay. So in this K-map, what all we have to study here is the different types of grouping, which is what is called as grouping, what is called as definitions for pair, pod, octet, overlapping of the cells here. Any graphical method of simplifying Boolean expressions. We will see the different layouts of K-map. In the layouts only I will cover all the definition. Okay. Layouts of K-map. 2-variable K-map. Here you will be studying 2-variable K-map, 3-variable K-map, and 4-variable K-map. 2-variable, 3-variable, and 4-variable K-map we will be studying here. First one, 2-variable K-map. How to draw the layout of 2-variable K-map. How to draw the layout. Layout means this will be fixed for the number of input variables. If the input variables only 2, that means the equation is having only A and B. The equation is having A, B, and C. If the equation is having A, B, C, and also D, then it is called as 4-variable. Okay. So in the 2-variable layout, what happens? There will be only 2 variables to represent in terms of K-map. Right? A has 2 possible values. That is, it can be either A bar or it can be A. B can be B bar or D. So what basically the concept is, the 2 variables will be having 4 combinations. The combinations are 0, 0, 0, 1, 1, 0, and 1, 1. So how many combinations are there? There are 4 combinations. That means it is always in the form of 2 to the power of n, where n depends on the number of variables. Okay. So for 2 variables, there will be 4 combinations. That's why there will be 4 blocks like this. Okay. This represents a 0, 1, 2, and 3. That means in terms of binary, this is nothing but 0, this is 1, this is 2, and this is 3. Okay. This is the layout of the 2-variable K-map, which can have the possibilities of. Now, what is represented in each cell? What is represented in each cell is the condition for the 2 variables, that means A bar and B bar. When both are A bar and B bar, that means they are forming cell number 0. This particular block is called as cell. Okay, cell. So what is the cell in K-map? Individual block that represents a product term. That represents a product term. It is individual block that represents a product term. What does that mean? That means here this block represents A bar, B bar. So this block represents what? This block represents A bar and B bar, right? This block represents A bar, B. This block represents A, B bar. This block represents AB, right? So each cell, so what is a cell in K-map? Individual block that represents a product term is called as, is nothing but what? Cell, okay? Is cell, right? So this is the layout. So we have covered the cell definition, we have covered the Karnaugh map definition, that is also called as K-map. Here we are moving with the layouts of for each different variable, that is having 2 variables, having 3 variables, having 4 variables. So here I have considered a K-map that is having 2 variables. Now let's move to 4 variable K, 3 variable K-map. Let's move to 3 variable K-map. Layout of 3 variable K-map. The layout of 3 variable K-map can be written in 2 forms. I am writing the first form. This is variable A, and beside the combination of B and C. What I have told you, total number of cells depends on the number of variables of n. Number of variables are n. Here the number of variables are 3. So 2 to the power of 3 makes a total 8 cells. 1, 2, 3, 4, 5, 6, 7 and 8 cells are there. This can take A bar and this is A. Right? This can take combinations of B and C. What combinations it can make, I will show you after writing the combination of BC. First is 0, 0. Second one is 0, 1. 0, 0, 0, 1. 1, 1 and 1. 0, 1 and 1, 0. 0, 0, 0, 1, 1, 1 and 1, 0 are the possible combinations of BC that can be made there. Next, 0, 1, 2, 3, 4, 5, 6 and 7. So these are called as the cell numbers. The cell numbers are made from the combinations of A bar, B bar, C bar. The next one, A bar, B bar, C. That means 0, 0, 1. Next, A bar, B, C. That means 0, 1, 1. Next, A bar, B, C bar, 0, 1, 0. That is 2. Next combination, A, B bar, C bar, 1, 0, 0. A, B bar, C. A, B bar, C. That means 1, 0, 1. Next, A, B, C. That means 1 1 1. The last one A B C bar. That means 1 1 0. This is the layout of three variable K map. This three variable K map can also be written in the other form. That is here this is C bar and C. Okay, first C bar and then C and A. 0 0 0 1 1 1 1 0. Okay, 0 0 0 1 1 1 and 1 0. This is 0. That takes 0 0 0. That means A bar B bar C bar. The next one A bar B bar C 1. A bar B C bar. That means 2. Next one 3. A bar B C 0 1 1. A B C bar 6 1 1 0. 6 A B C 7 1 1 1. A B bar C bar 4. A B bar C. That means 5. So this is the other form of writing the K map with three variables. Okay. This is the layout of three variable K map. What is most important for your exam point of view is the 4 variable K map. 4 variable K map. Okay. So how to plot the 4 variable K map? So 4 variable is 2 to the power of n. That means 2 to the power of 4 means 16. Okay. So total after 8 there will be total 16 cells here. Having the numbering 0 to 15. Here A, B. This side C and D. Okay. A, B, C, D. Right? This is how the layout is written. A, B, A, B, A, B, A, and B. Okay. C, D, C, D, C, D, C, D. Okay. 0, 0, 0, 1, 1, 1, and 1, 0. 0, 0, 0, 1, 1, 1, and 1, 0. Okay. A bar, B bar, C bar, D bar. All zeros, cell number 0. A bar, B bar, C bar, D. 000, 1. Cell number 1. A bar, B bar, C, D. 00, 11. Cell number 3. A bar, B bar, C, D bar. 00, 10. Cell number 2. A bar, B, C bar, D bar. 0100. Cell number 4. A bar, B, C bar, D. 0101. 0101 means cell number 5. A bar, B, C, D. 0111. That means cell number 7. 0111. A bar B C B bar 0 double 1 0. Cell number 6. A bar B bar C bar C bar D bar 1 1 0 0. 1 1 0 0 means cell number 12. A B C bar D 1 1 0 1. 1 1 0 1 means 13. A B C D all ones means 15. A B C D bar triple 1 0 14. A B bar C bar D bar 1 triple 0 that means 8. A B bar C bar D that means cell number 9 1009. Here this combination and this combination we have to frame here. Okay. A B bar C D that means 1 0 1 1. 1 0 1 1 means 11. A B bar C D bar A B bar C D bar 1 0 1 0 that is nothing but 10. So how to write these combinations and how to write the cell number. Right, this is the 4 variable K-map layout of the 4 variable K-map. Here you have to take the combinations of A and B. Here you have to take the combinations of C and D. A bar, B bar, A bar B, A B, A B bar, C bar, D bar, C bar D, C D, C D bar. These are the possible combinations of A this side and A B this side and C D that side. Right? So we have to check this row and this column and what particular combinations of A, B, C, D together this particular cell is forming. So this is called as particular cell of the K-map. The K-map cell is an individual block that is represented within with a number and that number is nothing but a product term. Here the product is formed from the combinations of A, B, C, D. Right? And for this particular cell, all the 4 variables A, B, C, D all are zeros. That's why we are representing it by A bar, B bar, C bar, D bar. Okay. So this is the first cell. Next, check this row, that column. Okay. A bar, B bar, C bar, D. Next, A bar, B bar, C, D. A bar, B bar, C, D bar. Right? That is giving you corresponding cell numbers. Those are nothing but 0, 1, 2 and 3. Okay. I'll also give you how to write the shortcut, how to write the layout. Okay. First understand what the layout exactly is. Next consider this row and this column, right? C bar, D bar. That's what I'm writing here. Combination of AB from this side and CD from this side. You have to just check for this particular cell which combination of AB is applicable and which combination of CD is applicable. Just write that together. That will form the product term of this particular cell, right? Same way here, A B C D bar, A bar, sorry, A B C bar D bar, A B C bar D, A B C D, A B C D bar, A B bar C bar D bar. From here A bar, from here C bar D, A B bar C D, A B bar C D bar. This is how the 4 variable K-map is formed, and from the combinations of A, B, C, D, each cell number is given particular value for that cell. Okay, this is having 0, this is having 15. Each cell is having its individual identity by the number that is given to that particular cell. Right? So we have discussed the layout of 2 variable K-map. We have discussed the layout of 3 variable and 4 variable K-map also. move in further with the four variable schema, where you will be coming across many concepts. With the explanation of that of those concepts itself, I will consider those definitions also. Okay, so now moving further with the schema, plotting, grouping. Okay, what is meant by schema, plotting and grouping. Coming to the two variable and three variable schematics, I have only shown the layout. With the further topics, I will be moving with the four variable schematic only. So I am drawing the four variable schematic again to show you what is called as plotting and grouping. A, B, C and D. Okay. So this is how the layout is drawn. While writing, first write down CD, CD and CD, AB, AB, AB and AB. Right? 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Right? So this is the possibilities of AB combinations and the CD combinations, right? Now, how to write the cell number inside? This is 0, 1, take a jump, 2 and 3. After 1, you have to write it 2, leaving one block, and again coming back to that block itself, you have to write 3. Right? This is how the layout has to be written. Next, 4, 5, take a jump, 6 and back 7. Okay. Now again, don't write here. Take a jump first. Okay. 8, 9, 10 and back 11. Now start writing here. 12, 13, 14 and back 15 here. Right. So this is called as layout of four variable schema. Now what is called as plotting? What is called as plotting means whatever expression is given in the form of, expression will be always given in the form of the mean terms, okay, plus the don't care terms. These are called as the mean terms. They are simply represented in the form of numbers 0 to 15. These are whatever number is given with sigma m are called as mean terms. Whatever terms are given with sigma d are called as don't care terms. Now I will tell you what are mean terms and don't care terms. Mean terms I have already explained you that those are the what we can say product terms. Okay, they are product terms in the sub form. Okay, in sub form each term is a product term. That particular term in its true and complemented form is called as mean term, right? So how many mean terms can be formed here when we have four variable k map? Then it can make combinations of 4 zeros to 4 ones, taking possibilities of zeros to 15. So this 0 to 15, any number can be present inside the sigma m, and those are called as mean terms. So these mean terms inside the k map should be entered as 1. Okay, has to be entered as 1. These are called as mean terms. So what are don't care terms? Whatever, again there will be some value between 0 to 15. This don't care terms will be having some value between 0 to 15. Any number that is written between 0 to 15 in this bracket are called as don't care terms, and inside the K map you should represent it by capital X. What does this capital X mean? Capital X means 0 or 1. Okay, so it gives you the liberty to take either 0 or 1 inside the K-map. Okay, how exactly it works you will come to know after making the plotting and grouping. While making the plotting and grouping, you will come to understand. For now, we just understand that the X can take either 0 or 1 depending on the requirement of the grouping you are making there. Okay, so it is completely depending on the user. Otherwise, whoever is simplifying the expression, okay, there are certain rules to consider it as 0 or to consider it as 1, right? So meters, any value between 0 to 15 written here has to be entered as 1 inside the K-map are called as sigma n terms here in any particular expression for K-map. Sigma d, known K terms are represented by capital X that can take either 0 or 1 value inside the K-map during the simplification, right? Now let's consider one of the examples, that is y is equal to sigma m certain values plus sigma d certain values. Okay, and the values are 0, 1, 4, 13 and 15. 0, 1, 4, 13 and 15, and the don't care terms 2, 5 and 7. 2, 5, 7 are the don't care terms, right? So what I have told you, these are called as min terms, and these should be entered as 1 inside the K-map and these should be entered as X inside the K-map. So this is the four variable K-map. 0, what cell number? So what are these? What is represented here in the middle or don't care terms indicate the cell number. So cell number 0, 1, 4, 13 and 15 should be entered as 1 inside the K-map. Whereas don't care 2, 5, 7, cell number 2, 5, 7 should be entered with X. Right? So let's do that. 1, 0, cell number 0 is mentioned there. Cell number 1 is also mentioned there. So 1. Cell number 4 is also mentioned. So I am taking it as 1. Cell number 14 is mentioned. 15 is there. Right? So these are the 1, 2, 3, 4, 5. Min terms mentioned there. Next, moving to the don't care terms, X. 5 is given, 2 is given, 7 is given. Just now, the step I have followed is called as plotting. So what is plotting? Entering the min terms, entering the given whatever expression is given, entering the given min terms and don't care terms. Don't care terms inside a K-map. A K-map is called plotting. Is called plotting, right? Entering the given min terms and don't care terms inside a K-map is called plotting. That means whatever, this is considered as first problem. Okay? Whatever min terms and don't care terms are given in the particular problem, that has to be, those has to be entered in the K-map layout, right? Before what we did, we just drawn 16 cells. We named each cell, we numbered each cell 0, 1, 2, 3 and so on. We took the combinations of AB and CD, right? Corresponding combinations. After this, the layout was ready. Okay? Layout for 4 variables was ready. After that, what we have done, depending on the given problem, depending on the given simplification, we have entered the min terms and don't care terms inside the K-map. This is called as plotting. Right? Now we have to do what? Grouping. What we have to do now? Grouping. Okay? So grouping is nothing but making combinations or groups, we can say. Okay, grouping we will take a simple word as group only. Making group of adjacent adjacent ones in a K-map. Adjacent ones means they should be next to the another are called as adjacent ones. So how grouping we can make? Again, this grouping comes with three types of groupings, that is pair, quad, octet. Pair means definitely 2, quad means 4, octet means 8. Right? That is called as grouping. Okay. So what is pair? What is quad? What is octet? We'll see now. Considering the same example, I am giving you the definitions as well as I am solving this problem also. Right? Two adjacent ones. Group of two adjacent ones in a K map is called as pair. What? Group of four adjacent eight adjacent ones in a K map is nothing but octet. Okay. So these definitions are very, very important for exam point of view. Will be asked for 1 mark. Okay. What is pair? What is quad? What is octet? Right? Or define pair, define quad, define octet. Can be the question. Okay. Now, what exactly grouping is? So grouping, making group of adjacent ones in a K-map in the form of pair, quad, or octet. Okay, is called as grouping. So I make first group here. This is the first group, right? This is the first group. Now this is the second group. So this is called as grouping. You have to take certain measures while grouping, performing grouping in the K-map. The combinations of four ones or 8 ones or 2 ones should not be random. That's why they are mentioning in the definition also adjacent. And the combination should be in the form of rectangular form. That means if the 4 ones are like this, it should be in the square form. Okay. Here rectangular form, otherwise the square. You should not make a group of fours like this. That is all the wrong method of making the groups, right? We can take group 1 here and group 2 here. This is the only possibility of taking the groups. Now concentrate on the don't care conditions. So where all I have taken the don't care conditions, x, s and x, that means that 2, 5 and 7, right? 2, 5 and 7. The 2, this one, we have considered it as 0. What the don't care condition said? You can consider them either as 0 or as 1s, right? So this particular don't care term is considered as 0, whereas these two are considered as 1 because they are considering them inside what? Inside our grouping. We are considering these two x inside our grouping as 1s, right? So these don't care terms are considered as 1, whereas this don't care term is considered as 0. So this is how the grouping is done. Next, redundant bit. Redundant bit. What does it mean? What is the meaning of redundant bit? This is called as redundant bit because it appears in both the groups. Right? The bits which appear in more than one groups are called as redundant bits. Okay, not redundant group. I will tell you the definition of redundant group also. The bit which is repeated in more than one group is called as redundant group. These are not redundant bits. These are not redundant bits because they are appearing in separate or individual group only. They are not repeated in any other group. So this is called as redundant bit. Right? So this is how grouping is done. Making the expressions and all, I will teach you in the next class. Now, try to understand how to plot, how to make the groups. Extracting, next step will be extracting the expression and then from the expression drawing the logic circuit using basic gates or AND gates will be the next step, right? So, I will tell you what are all the possible steps inside a K-map. So, this is the question we have considered here. So, steps. First, draw the layout. Okay, first step. Then, once the layout is ready, plot. Plotting. Okay. Third, grouping. Fourth step, finding expression. From the groups, we can find the expressions. How it is done, I will tell you. Then finally, realization. Realization of what? Realization of expression. What expression? Final simplified expression, whatever you have got, you have to realize that using basic case or NAND gates, right? So these are the steps. So what all you have studied now? Layout. You have studied layout for all 2, 3, and 4 variables you have studied, right? Then plotting inside the layout, how to plot, and then grouping, how to make the grouping of adjacent ones inside the K-map, and then finding the expression and realization of the expression is left now. Okay. So this is the summary of how to perform simplification of any Boolean expression using K-map. These particular 5 steps has to be followed. So here grouping is done. I will consider the other definition. So what are definitions we have covered here? What is grouping? What is plotting? What is pair? What is chord? What is octet? Redundant bits also. Now what is redundant group? Right? For example, consider that this is one group, this is another group, right? So we will remove this one. I will consider a new example. What is meant by redundant group means that group which is already existing in all other groups. Okay, and the redundant group can be eliminated while writing the expression. Okay, this is called as redundant group. This is also asked in 1 mark. This is the layout for 4 variables. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is how you have to draw the layout. AB, CD, AB, 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 AB. Okay. CD, 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 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay. So now this is 1, this is 1, this is 1, and this is also 1. Okay. This makes a quad group of 4. Okay. This is 1, this is 1, this is 1, and this is 1. So this also makes a quad. Quad. Let's name it as quad 1 and name it as quad 2. Both are in the square form. Right? The two different quads. This is grouping 1, this is grouping 2. This is giving you quad number 1, this is giving you quad number 2. Right? In the square format. That means they are formed in a square format as group. There is also possibility of another group, that is this one. Okay. Let's name it as quad 3. This is also quad which is having 4 number of ones, but it is in the rectangular format. That means all the ones are in the straight line. Okay. Here the ones are one beside one another and two below and two over that. Okay. In the square form, this quad is in the rectangular form. Right. So this quad 3 is nothing but redundant group. Redundant group. Okay. Why we call it as redundant group? How many ones it is having? 1, 2, 3, 4 ones. These two ones are already present in quad number 1. Whereas these two ones are already present in quad number 2. So there is no point in making a group again. Okay. That's why it is called as redundant group. Even though it makes a group, this is also a group. It is also a valid group in the K-map, but it is not required. Such groups are called as redundant group. While writing the expression, we can omit, otherwise we can just skip this group. How that exactly functions, you will see by solving the problems, right? So this is quad number 1, this is quad number 2, whereas the quad number 3 is not required for making the finding of the by finding the expressions. Okay, but it is also a group. Such groups are called as redundant groups. Okay, so what is a redundant group? It is I will write the definition. It is a group of adjacent. Is a group of adjacent ones in a K-map. K-map. It is a group of adjacent ones in K-map. Okay, whose all ones are overlap. These are also called as overlap. Otherwise, all the ones are already existing in other group. In other group. In other group. In other group. So what does this mean? Other group. Already present. All ones are overlapped, otherwise are already present in other group. Right? So these ones are already part of other group. Such group is called as redundant group. Okay. So we have studied the plotting of the K-map or layout of the K-map. In layout of the K-map, we have studied two ways how to realize the Found expression. Whatever expression now we are going to get, that expression has to be written in the form of, otherwise the corresponding logic circuit has to be drawn using basic gates or NAND gates, right? So that we will study in the next class. Thank you, students.